Welcome, kids, to more solving equations. So I have to redeem myself after all my mistakes in the previous video. I do apologize. I believe at this point I have edited all of them into the video with the little speech bubbles, and hopefully we went over the problems in class as well. So we're going to look at some more practice solving equations tonight. And we have the 4 equations from your pre-assessment, as well as a couple others that I have thrown in. So let's jump right in and get started with the first one. Solve for m. We have n equals 4/7 m plus 12. If you want to give it a shot on your own, copy it down, pause your video, and give it a shot. Otherwise, I'm going to go ahead and jump in. I'm going to use this nice purple. Alright, so we're trying to isolate the m here. So n is equal to 4/7, I don't like that. Hold on. Okay, 4/7 m plus 12. And we're trying to solve for m. So I'm going to underline it. That's the one I want to solve for. So I'm going to start just as I did before by undoing what was done to the variable. So we have a coefficient of 4/7, but I'm going to start by getting rid of this 12 because I usually start with addition and subtraction, and that comes after multiplication in the order of operations. So it's the adding 12 came after the 4/7 multiplied by m, so that's what we want to get rid of first. Now I want to go ahead and get rid of that fraction. And remember, I can do this a couple of different ways, but the easiest way is to use our multiplicative inverse property. So we're going to be multiplying both sides by the multiplicative inverse of our fraction, 4/7, and the multiplicative inverse or reciprocal of that is 7/4. Now notice, there's really no reason for me to do any distributing over here, because 7/4 n, I'm not going to be able to simplify that anyway. So this fractions cancel here, and we just have m. I'm going to use my symmetric property and flip it around. 7/4 times the quantity, n minus 12. And you don't want to write that any other way. There is no other way to write that. You can actually check this solution by plugging this in for m into the original equation. That sounds a little confusing, and it's a little beyond the scope of what I want to do in our class. So I am, of course, going to check all of the other equations to make sure, the regular equations, to make sure we have our answers correct. But in this case, I just have to double back and make sure I did the right thing. So I'm minus 12, both sides, n minus 12 multiplied by the reciprocal. Yep, that looks right. Let's move on to the next one. This one's very close, very straightforward. If you want to go ahead and copy it, solve for h. V equals L times W times H, so the volume of a prism. Go ahead and copy it and pause your video, give it a shot. Otherwise, I'm going to go ahead and jump in myself. Now, I promise actually to solve for h. It's helping me here if I go ahead and I actually underline the h. Alright, so I have L times W times H. I want to divide off what was multiplied by h. So I want to divide off L and W. And that's going to leave the h by itself. So h equals, again, my symmetric property, V over LW. So if I have the volume and the length and width of a prism, I can find the height. Okay, so that's 2. Let's move on to the next one. Alright, so a couple of ugly fractions here. We have solve negative 3/4 times the quantity x minus 8, which equals 1/2 times the quantity 6x plus 5. Okay, copy and solve. Pause your video. You can start it back up again. But here we go. We're going to distribute first. So negative 3/4 times x. Negative 3/4 times a minus 8. The next sign I'm going to see is addition, because it's like a negative times a negative. And I want 3/4 of 8. Well, 1/4 of 8 would be 2. 3/4 of 8 then would be 6. On the other side, again, we're going to distribute, so 1/2 multiplied through the parentheses, so we're going to have 1/2 times 6x, or 1/2 of 6x, or 3x, plus 5/2. 5 times a half, 5/2. Now you know me, I'd rather not deal with the fractions, I'd rather just make them go away. So we're going to multiply the entire thing by the least common denominator of the two fractions that you see. So we have 4 and we have 2. Well, 2 goes into 4. Therefore, our least common denominator for this actually is 4. So I want every single term multiplied by 4. So negative 3/4 x times 4 plus 6 times 4, every term. 3x times 4 plus 5/2, again, times 4. So negative 3/4 times 4, the 4s are going to cancel. I'm going to get negative 3x plus 24, which equals 3x times 4. A lot of kids are confused. Can I multiply that? See, I thought they weren't like terms. Well, Like terms has to do with adding and subtracting, not multiplying. You can indeed multiply 3 times x times 4. You're just going to use the commutative property and do 3 times 4, which is 12, then times x, 12x. And finally, 5 halves of 4. Well, 1 half of 4 would be 2, so 5 halves of 4 would be 10. Continuing, I'm going to add 3x to each side, because that is the smaller value of our variable. Alright, I'm going to flip it around with my symmetric property. I'm going to subtract 10 from each side, leaving 5x equals 14. Excuse me, 15x equals 14. And finally, I'm going to use my multiplication property of equality. Divide by 15, x is 14/15. Now, I think I said I was going to check all of them, and I'm going to check this one with a graphing calculator, which I will encourage you to do also in class. This is the kind of problem a graphing calculator was made for in terms of checking, because it's too complicated to do without it. And I know I did, yes, I totally did just say that. Too complicated. It's much easier just to be able to plug that number in for each side of the equation and check that way. So we're going to continue. We have, I think, 3 more equations. Solve 7 times the quantity d minus 2 minus 5 times the quantity 2d plus 2 equals 18. So we've already established through everything we've done in class that we must distribute here first. We've also established that there is something a little iffy about this part in here, where we're distributing with that minus 5 multiplied through. So that is something we are going to have to focus on here as we go. Alright, so 7 times d, 7d. Minus 7 times 2, 14. Minus 5 times 2 is going to be minus 10d. Minus 5 times a plus 2 is a minus 10. It's like a negative times a positive. Equals 18. We're going to combine our like terms. 7 minus 10 is negative 3d. Minus 14 minus 10 more is minus 24. Okay, you with me so far? Think of it as negative 14 and negative 10. It's negative 24. 7 and negative 10 is negative 3. I can add my 24 to each side. I like this green color. It's very nice. So that's going to be 42. Double check my math, please. And finally divide. Good chance to review short division. Dividing by negative 3 here to get positive d. Negative answers. It's a positive divided by negative. 3 goes into 4 once with 1 left over. 3 goes into 12 14 times. Our solution is negative 14. Okay, so I'm going to go ahead and plug that in backwards and check. I'm not going to record through doing it by hand. I'm just going to go ahead and write it down. So I'll pause it and check my answer. And there you have it. It does indeed work when you plug in negative 14. So a complicated problem because you had to distribute that negative, but not so impossible that we couldn't go ahead and figure that out. Here we have not a chemical, but a science formula that should look familiar. F equals 9/5 C plus 32, and that is F for Fahrenheit, C for Celsius. This is the conversion formula for temperature between Fahrenheit and Celsius. So this would be if I have a temperature in Celsius and I want to convert it to Fahrenheit, but what if I want it the other way around? What if I had it in Fahrenheit and wanted to convert it to Celsius? So we are going to go ahead and solve for C on this one. Solve for C. So first, again, we think about what was done to C. C has a coefficient, and then has a constant added. So a coefficient, and then a constant added over here. So we're going to get rid of the constant first. So F minus 32, remember, I can't actually do that, so I just leave it F minus 32. And this is very similar to the first one that we did, because now we're going to finish it off by using our multiplicative inverse property, which has us multiply by 5/9. Okay, so we have 5/9 times the quantity, F minus 32, and that equals C. So if I have Celsius, if I have Fahrenheit temperature and I want to find Celsius, I subtract 32, which probably has something to do with the freezing point of water, because that's 32 degrees. Subtract 32, and then I find 5/9 of the answer, and that converts the temperature for me. All right. And here is our very last one. So big distributive property example, 3 distributive property sections. Go ahead and pause your video, try it out, and let's see what you get. But I'm going to go ahead and solve now. So I'm going to distribute first. 6x minus 14 plus 4 times 3x is 12x plus 8. And that equals 30x plus 54. That got a little messy there. Let's fix that. Well, I erased a little more than I had to. Alright, 30x plus 54 plus 3. So this side ends up, when you combine like terms, being 18x minus 6. And here we have 30x plus 54. Alright, so I'm going to subtract the 18x because it's smaller. It makes it easier for me to get to my solution. So we're simplifying down long before we finish the problem, simplifying it all the way down to here. And then from there, it's that same process over and over again. Subtract the 54, that's going to be negative 60 equals 12x. Divide by 12. It's the last step. X equals negative 5. So it will get easier. Remember that you want to go ahead and spend some time practicing what we're learning. You can find some good links online. You could go to Khan Academy, and I'm sure we could find you some good problems over at Manga High. Alright, guys, I will see you in class.